Hello, now we are going to be practicing our exam technique again, and we are going to be using 2018 paper 1 question 1 as an example, and I'm going to be showing you the structure of this. Now this is a 3 variable simultaneous equation. You have to be extremely careful with your timing in these questions. It's very easy to get bogged down in them, so I would generally keep them till the end of the exam when you've definitely got your timing down for other stuff. But you can do these questions at the beginning if you really want to. Just make sure that you are keeping a very, very close eye on your timing. So we are going to look at this, and I know that I'm going to want an x, a y and a z as my final answer. So x, y, z for final answers. So I write that down so I don't forget. And there's no other restrictions, so let's jump into it. I'm going to write these down carefully, and I know I want to eliminate variables. I want to get down to the point where I have an equation or equations with 2 unknowns and then 1 unknown. Plus 2y plus 2z is equal to 14, and x minus 3z equals minus 13. The most common error in these questions comes from making a mistake when you take them down, so be careful of that. I think I'm going to try and eliminate the y because I have an equation that already has only 2 variables in it, so I'm going to get rid of my y's, so I'm going to multiply my top equation by minus 2 and my middle equation by 3. Again, the aim being to get rid of my y's. So I'm going to call this equation 1, equation 2, equation 3. Label your equations. That's another big skill in these type of things. Otherwise, you can very easily lose track of what you're talking about. So multiplying that out, I get minus 4x minus 6y plus 2z is equal to 8. And 9x plus 6y plus 6z is equal to 42. Then when I add these two together, again, tell yourself what you're doing and tell the examiner what you're doing. So when I add these together, I get 5x plus 8z is equal to 50, and I'm going to rewrite my third equation. Now I've got something in x and z. I'm going to rewrite my third equation from the beginning. So I'm going to call this equation 4, and this is again equation 3. Now I want to get rid of a letter. The easiest one by far here is getting rid of the x, so I'm going to multiply my equation 3 by minus 5. I don't have to do anything to equation 4. So I get 5x. Rewrite your equations in order each time. Massively reduces the chances of making an error. Plus 65. Be careful of something like this. You want to make sure your zeros definitely look like zeros. I add those two equations together, and I get 23 z is equal to 115. Divide both sides by 23, and we get z is equal to 5. Now it comes down to substituting. I have an equation with z and x, so my next port of call is going to be to find x. So write down the equation you are going to sub into. Do not skip that step. Z is equal to 5. Subbing in. Always put brackets around anything you sub in. It minimizes the chance of errors. Minus 15 is equal to minus 13. Rearranging, x is equal to 2. Another thing I forgot to do. Z is equal to 5, I should underline. X is equal to 2, I should underline. There'll be a big mess of writing on this page. You want to make it easy for yourself to find key pieces of information. Now I want to find my y value, and I think the top equation is the easiest one to sub into. You can use either of the top two equations, but look for the ones that have the smallest amount of multiplication, the least messy of your options, because the messiness of these questions is what costs you marks. So that's my setup. I now sub in. Everything in brackets when you sub in. Don't skip steps like trying to move things around in your head. Do things step by step like this. If you make a mistake, it'll be a lot easier for you to come back and work out what you did. So now I have my x, my y, and my z, and I'm able to write them in here. Y is -1, z is 5. If you follow these steps where you're labeling everything and you don't try to skip ahead too far, these questions can be very reliable. But under exam pressure, it's easy to start trying to skip around, and if you get yourself muddled and don't keep track of what you're doing, you can lose your place in these questions and they can get very messy. So I am now going to go to part B of that question. And we're going to look again, 2018, paper 1, question 1, and we're looking at part B, and this is an inequality. This is a very common question to catch students out, so be careful of it. We're going to do our initial setup, read the question. I recognize I've got an inequality here, so I'm going to probably end up with a range of values of x, and I'm also going to write down my key pieces of information. So I have x is going to be in some range of values. And I've got x is an element of the real numbers. That could be important in some questions. Or x is not equal to -2. Something like this will almost always come back in the final question for getting full marks. So I've written that out. If I didn't recognize that x had to be in a range of values, don't worry too much about it, but definitely write down x. So answer x. And write down your constraints, certainly. Now, let's jump into it. We've got 2x minus 3 all over x plus 2 greater than or equal to 3. Now I'm going to do the key piece that gets me my first block of really good marks here, is recognizing that I must multiply both sides by 2x, or sorry, x plus 2 squared. Why must it be x plus 2 squared? Because if I multiply my inequality by a negative number, I have to swap around my inequality sign. So this would have to go to being a less than or equal to sign if I multiply by a negative number. I don't know whether I'm multiplying by a negative number because I've got stuff involving x. I know I'm multiplying by a positive number if I have something squared. So I can't multiply both sides by x plus 2 to get rid of the fraction. I have to multiply by something that's guaranteed to be positive, which is x plus 2 squared. So I have a common factor top and bottom here, so I'm left on the left with x plus 2 on 2x minus 3. I don't have to do anything with this. 3 on x squared plus 4x plus 4. Multiplying this out, x squared, 2x squared minus 3x plus 4x minus 6, 3x squared plus 4x plus 12x plus 12. So I've multiplied everything out. I recognize I've gotten a quadratic something, so now I am going to need to do some rearranging. For a quadratic means bring everything over to the left hand side, get it equal to 0. So rearranging that, I end up with minus x squared minus x squared minus 11 x minus 18 greater than or equal to 0. Now, I don't like factorizing something with this many minuses in it, so what I'm going to do is multiply both sides by minus 1. So multiply everything by minus 1. What effect is that going to have, other than changing the signs of my symbols, is this must flip around. This is why we had to multiply by our x plus 2 squared earlier. We are multiplying by a negative, so we are going to need to change around our symbol. Now I'm looking for effectively the roots of this in order to solve. So this is one of the funny things in these questions. We go from dealing with an inequality, and for a little while we end up writing a equal sign. You don't have to, but it is technically what you're doing. You're finding the roots of this equation, the roots of this inequality. So we're looking for where this equals 0. We can factorize that and get x squared, x plus 9 and x plus 2 equal to 0. X plus 9 is equal to 0. X plus 2 is equal to 0. So x is equal to minus 9 and x is equal to minus 2. Might jump out at you. X cannot be equal to minus 2, so this is going to have an effect later. Now, how do I figure out how I'm going to do my greater than or equal to signs? Because this was for an equality and I'm dealing with an inequality. As you're used to me saying, draw a picture. So draw a very rough sketch. I know that I have a positive quadratic. So I've got a smiley face, and I know that its roots are at minus 9 and minus 2, and I'm looking for when it is less than 0. So less than 0 is this area down here. So I'm looking for the area between minus 9 and minus 2. Therefore, I am going to have x being greater than minus 9, greater than or equal to minus 9, and greater than or equal to minus 2. Now, just from my picture, I would have a greater than or equal to here. But because I've been clever and I've written down my information here, so I'd have my minus 9 and minus 2 for my final answer, I recognize that I can't have my equal sign going on there. So I'm going to rewrite that bit as less than minus 2, because I cannot have it equal to minus 2. Now let's have a quick look at the marking scheme and see how we get on. So we see for part B, I'm doing this a little bit backwards, but for part B, low partial credit, 30% for the question is any use of or multiplying both sides by x plus 2 squared. You can also get 30% in this question by just trying to rearrange this as a linear equation, so multiplying both sides by x plus 2. The maximum amount of marks you can get there is 30% for the question, but that's not nothing. So even if you don't remember exactly what to do, just trying to rearrange this would have gotten you 30% in this question, so building you up towards a pass. And then you can see the sketch, so it's not just me who's drawing the sketches. And then for our next block of marks, we're getting the quadratic inequality involving 0. So you're looking for recognizing you've got a quadratic here and rearranging it. So that gives you your middle block of marks and roots found, but you forgot to draw your picture and get your range of values would be your 80% for the question. Now if we go back up to part A, if we go back to our simultaneous, we have matches coefficients in two of the equations. So if we make one of our correct steps, we get our first block of marks, and we've got again 30% for the question. And then to get around 50% for the question, we find one of our letters. So we've got 50% for our question by the time we've got one of our letters. And that's what we need for practicing our maths.